Welcome to Understand the Math. In this video, we're going to walk through two example problems and learn how to graph these polynomial functions by analyzing their end behavior, identifying their zeros and multiplicities, and then sketching the overall shape of the graph. Let's start with a quick overview of the steps that you should follow when graphing any polynomial function. The first step is to determine the end behavior. The end behavior of a polynomial describes how the graph behaves at each of its ends. On the left, when x goes to minus infinity, and then on the right, when x goes to positive infinity. The end behavior can be determined by looking at the degree of the polynomial and the leading coefficient of the polynomial. I've constructed a chart here just to make this a little bit easier. If the degree is odd and the leading coefficient is positive, such as with the function f of x is equal to x, graph down here, the graph goes down on the left and up on the right. If the degree is odd but the leading coefficient is negative, as with the function f of x is equal to minus x, then the graph goes up on the left and down on the right, just the opposite of f of x is equal to x. Now let's look at what happens if the degree is even. If the degree is even and the leading coefficient is positive, as with the function f of x is equal to x squared, then both of the ends go up. And if our function is even and the leading coefficient is negative, as with f of x is equal to minus x squared, then it's just the opposite and both of the ends go down. After you determine the end behavior, you want to find the zeros and their multiplicity. To find the zeros, all you have to do is set each factor equal to 0 and then solve for x. And then to find the multiplicity of the zero, you just have to look at the exponent of each factor. Let's look at this function f of x and see how this works. If the multiplicity is 1, then the graph crosses the x-axis. If the multiplicity is 2, then the graph touches the x-axis and then turns around. And then lastly, if the multiplicity is 3, the graph crosses the x-axis but flattens out before crossing. And then the last step to graph a polynomial is to just sketch the graph and put all of this information in it. Let's now look at our examples. In our first example, we're going to graph the function f of x is equal to x times x minus 2 times x plus 2. The first thing that we're going to do is to determine the end behavior. Let's start by writing down our function. We have f of x is equal to x, and I'm going to put a 1 there so we can see its multiplicity. And then we have an x minus 2 raised to the first power, and then an x plus 2 raised to the first power. If we were to multiply all these factors together, our leading term would be x cubed. So I'm just going to say that this is equal to x cubed plus ... To find the end behavior, we need to find the degree and the leading coefficient. Our degree is equal to 3. So let's write down degree is 3. And then our leading coefficient is just equal to 1 because there's a 1 multiplying x cubed. So let's just write down leading coefficient is equal to 1, and that is greater than 0, so it is positive. Our degree is odd, and then our leading coefficient is positive, and that tells us that our end behavior is going to go down on the left and then up on the right. Now let's find our zeros and their multiplicities. We're going to find the zeros by setting each factor in our polynomial equal to 0. So our first factor is x, so let's set x is equal to 0. And then our next factor is x minus 2, so let's set that equal to 0. So we have x minus 2 is equal to 0, and that gives us x is equal to 2. And then we'll look at our last factor, x plus 2, and we'll set that equal to 0. So that gives us x is equal to minus 2. So those are our 3 zeros. Now let's look at their multiplicity. Each of the factors were raised to the power of 1, so all 3 of these are going to have a multiplicity equal to 1. So let's go ahead and write that down. We'll say m is equal to 1, m is equal to 1, m is equal to 1. And whenever we have a multiplicity of 1, our graph is going to cross the x-axis at the 0 point. So let's just write down that it crosses for all 3 of these. In our next example, it won't happen that all 3 of our roots will cross the x-axis. Before we go on, I just want to highlight our zeros because the next step is going to be to sketch our graph, and we're going to have to know what these zeros are. So let's now sketch our graph. We're going to use all of the information that we found. In our first step, we found the end behavior, and we found that on the left, it went down. So I'm just going to write a line just like that. And then on the right, our graph goes up. So I'm going to put a line like that. That's just going to tell us kind of the general shape of the graph. Now let's go ahead and let's put down our zeros. We have a 0 at x is equal to 0. And then we have a 0 at x is equal to 2. And then we have another one at x is equal to minus 2. Our graph is going to cross at all 3 of these points. So I'm just going to put some lines here so that we can see the direction that the graph is going. Since we're starting on the left at the bottom, at -2, we're going to cross like this. And then we're up above the x-axis. So when we get to 0, we're going to cross like this. And then when we get to 2, we're going to have to come back up across the x-axis, and it's going to go like this. Now we can go ahead and just sketch what our graph would look like. It's going to come up. It's going to go back down. It's going to go down and then come back up. And then it's going to continue going up. And that's the general sketch of our graph. If you need to know the exact y values, all you have to do is pick a few points for x, plug it into the function, and see what the y values are. Let's now look at a little bit more complicated example. In our second example, we're going to graph the function f of x is equal to x plus 2 times x minus 1 quantity squared times x plus 1 quantity cubed. Just like we did with our first example, we're going to start by determining our end behavior. Let's go ahead and let's write down our function. Our f of x is equal to x plus 2. I'm going to put a 1 there so that we can talk about the multiplicity. And then x minus 2 squared. And then x plus 1 cubed. Let's first find the degree. To find the degree, we're going to need to add up the exponents. That's adding 1 plus 2 plus 3. So this gives us x to the 6th as our leading term. And there's a 1 multiplying each factor, so we have a 1 in front of the x to the 6th. Our degree then is equal to 6. And let's mark this as even. And then our leading coefficient is equal to 1, and that's positive. Our function has an even degree and a positive leading coefficient, and that tells us that our graph is going to go up on each end. So let's just write down up, comma, up. Now let's find the zeros and their multiplicity. We're going to take each of our factors and set it equal to 0. Let's look at our first factor, x plus 2. We're going to set that equal to 0, and we'll solve for x. And this gives us x is equal to minus 2. And because our exponent was a 1, our multiplicity is equal to 1. Now let's look at our next factor. That is x minus 2. We have x minus 2 squared. Set that equal to 0. This gives us x is equal to 2. And our exponent is a 2. So our multiplicity is equal to 2. Now let's look at our last one. It is x plus 1 quantity cubed. So we have x plus 1 cubed is equal to 0. Solving for x gives us x is equal to negative 1. And then our exponent is a 3. So our multiplicity is equal to 3. Before we go to sketch the graph, let's highlight our zeros. We have x is equal to negative 2. We have x is 2. And then we have x is equal to negative 1. Now we can go ahead and sketch our graph. Our end behavior we found was up on the left and up on the right. So I'm going to write a little pink line and I'm going to go up on the left and up on the right. Now let's go ahead and let's plug in our zeros. We have a 0 at negative 2. We have a 0 at 2. And then we have a 0 at negative 1. Now let's write a small pink line to indicate what happens at each of our zeros. At x is equal to negative 2, right up here, we have a multiplicity of 1, so our graph is just going to cross. And then at x is equal to negative 1, we have a multiplicity of 3. That means our graph is going to cross, it's going to come up, and it's going to cross, but it's going to flatten out as it crosses. Now let's look at our last one. X is equal to 2. We have a multiplicity of 2, which means our graph is going to touch and then turn around. So I'm just going to draw a straight line right there. Now let's go ahead and sketch our graph. Our graph is going to come down, and then it's going to turn around and go back up, but it's going to flatten at this point. And then over here at 2, it's going to touch. So we're going to go all the way down over here and we're going to touch and then go back up. And that's it. I hope that you now feel more comfortable knowing how to graph a polynomial function and you feel ready to do problems like this on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.